For today, I thought we would look at the shape files and the coverages and the file geodatabase and raster data sets, and sort of get an idea of what these different formats are, and and how they show up on your hard drive, as well as how ArcGIS views them. So what I'm using is ArcCatalog. This is ArcCatalog in 10. The first data format that I want to talk about would be the shapefile. And the reason I'm starting with the shapefile is because it's the most widely used format. It was developed after the coverage data set. It's a very simple format. It has been published. The format's been published, so a lot of third-party vendors have used it. And inside catalog, a shapefile format or data format looks like this. Over here on my left side, I've got data formats. I have these different icons which Catalog uses to help you identify your data. And this particular one, I'm going to look at just New York counties, is a shapefile. And with this little icon, it shows up as a polygon shapefile. And with Catalog, we can preview the data, and so yes, indeed, it is a shapefile, and there it is. And we can look at the tabular data as well. A shapefile has tabular data associated with it. Every one of these formats has a tabular data set associated with it, because that's the whole power behind the GIS. So in shapefiles, this is the data set, the tabular data, and they always have these two, an FID, a feature identifier, and a shape field that tells the system what type of geometry you're looking at. With a shapefile, we can have points, lines, and polygons. All the other fields are fields that the user can manipulate and add to and remove. That's these through here. These are all additional fields. So let me just pull up a little descriptive information on the shapefile, because it's kind of a misnomer. We call it a shapefile, but the shapefile structure really requires at least 3 separate files in order to be functional. In ArcCatalog and the ArcGIS system, all you're going to normally see would be a file called .shape, have a .shape extension. What kind of icon you see is going to depend on whether you're displaying points, lines, or polygons. Now, there are a lot of other extensions associated with the shapefile. These are the 3 extensions that you will see mostly on your hard drive: SHP, SHX, and DBF. And I'll come back and look at these others later. But what I mean by these extensions and what you'll see on your hard drive is when you go out to the hard drive system and look in Windows Explorer, what is it that you see? And so I'm going to pop up a Windows Explorer, which is centered on my folder that I'm looking at, and here's data formats, and I'm going to key into the New York counties, which was the one that we were just looking at, and all of these files here are part of what is called New York counties .shape or shapefile. As I mentioned, there's more than one. This is the one that right here that ArcGIS displays to you and uses as the placeholder for all of them. But really, it needs a minimum of 3. It needs that one, and that one. It needs those 3 files: a DBF, an SHP, and an SHX file. Those are the 3 required files for a functional shapefile format data set. All the others are additional files that provide other information. PRJ is a projection file, so it will tell the system where in the world this data set resides, and then it can do a projection on the fly to match other data sets. If this file is missing, then it won't be able to do the projection on the fly. These other files are spatial index files, They can be rebuilt easily. This special little file you see here is a lock file. That comes and goes in ArcGIS. As I open it up in ArcMap or ArcCatalog, it locks the file so they can't be used by someone else or modified while I have it open. And then these others, this other one called .shape.xml, is actually where the metadata is stored for the shapefile. So if we go back to this this page here, if you go down and look at the shapefile information, and you can just type in shapefile extensions and you'll get this page. And then you'll see that here's the SHP, the SHX, and the DBF. Those are the required. And the DBF is a DBase file that's storing all of our attribute data. And the SHP, again, it stores the geometry. And the SHX is an index. And then the others are listed down here. Some of them we have up here. Others we haven't created yet for whatever reason. So at a minimum, a shapefile are these top three files: SHP, SHX, and DBF. If you're going to give a shapefile to someone or whatever, make sure you give them at least those three files, or else the data is corrupted and they won't be able to use it. So as I mentioned, this file format is very widely distributed. It's very well documented, and many third-party vendors are still using this. Now, the other file structure that's heavily used now is called the file geodatabase. And let me go to what the file geodatabase looks like. And the file geodatabase in ArcGIS, in ArcCatalog, has this icon used for it, which is essentially a cylinder. And the reason they're using that is because they think of the file geodatabase as a container that contains many different data sets. Now the shapefile, that was a single data set. It could hold either points, or it could hold lines, or it could hold polygons, and that's it. Always holding vector data. But that has limitations, obviously. We have a lot of files to manage on the hard drive. There's limitations on what you can do within the shapefile itself. The relationship of one polygon to another, there is no relationship. Polygons that are adjacent do not know they're adjacent. So to overcome those restrictions and to give the user a data format that would encompass all the data sets that ArcGIS uses, they developed a file geodatabase. Within ArcCatalog, it gives it this little icon, a container, and if we expand the container, we can see this is the file geodatabase and how it looks. These individual pieces within the file geodatabases, these data sets, can be vector data, as in these parcel data sets. I can preview them just like a shapefile. They can be vectors, they can be lines, and they can be points. So it's very similar. You think, oh, that's not much different than a shapefile. But the storage is very different than a shapefile. And the capabilities that you have with this data set within a geodatabase is very different. You have the capabilities to do such things as build a network within the geodatabase, of a road network that you can use for manipulations. You can build a stream network. You can build topology between the polygons, so that every polygon would know which polygon is adjacent to, and how they match up, and which boundaries are common, and things like that. You can impose rules and things like that you might need on your data, so that perhaps zoning boundaries have to match parcel boundaries. You can do all of that within the geodatabase structure, and that's why they developed it. It is to expand the capabilities and give you much more control over your data set, to both store it and manipulate and to control the data quality. So that's just a little bit as to why they developed the geodatabase. If I bring it up, and within ArcCatalog, it looks the same, just like a shapefile, just pops up there, and all the pieces are there. And they have a number data sets that can go into a geodatabase. As I mentioned, they refer to it as a container, and it can store feature classes, which is their name for what we would call vector data. So a feature class is essentially a vector data inside a geodatabase, and it can store the data sets. A data set it's a grouping of feature data of data based on this. One of the requirements is to have the same projection. So the interesting thing about geodatabase is everything inside of it can be a different projection. It doesn't care. But once you create this thing called a feature data set, it then says everything inside of this is the same projection. So a geodatabase, as I pull this down a little bit right here, this is the geodatabase, and this little strange icon here identifies a feature data set. And that can have inside of it feature classes. So you can have, so again, the geodatabase is our container, and it can have these sub-containers, if you want to think of them that way, that store data that's all the same projection, or it can just contain a number of separate data sets that may or may not have the same projection. So that's sort of a real brief overview of the file geodatabase. One of the reasons for coming up with a file geodatabase is the size limitations that were associated with both the shapefile, just because of the massive sizes that we started getting into, and why we're drifted away from something that was called a personal geodatabase a few years ago. Is the size limitation. The file geodatabase allows you to go very large with your data sets, as you can see by this size limitation. By default, you have 1 terabyte, so your file geodatabase can grow to 1 terabyte in size. Now, that sounds like a lot, and it is. The personal geodatabase could only go up to 2 gigabytes, and at first glance, that sounds like a lot. When you start dealing with vector data, that is a lot. However, the file geodatabase can store all kinds of data sets. It can store vector, it can store raster, it can and it can store images, it can store things called blobs, all kinds of different data types can be pushed into this geodatabase. And that's why you need something that can grow to a very large size. Okay, so that's the geodatabase, the file geodatabase, as to how ArcGIS sees it. But what does it look like on the hard drive? What does this structure that we see over here look like on the hard drive? And we'll come back to our folder, our Windows Explorer, and we'll just scroll up a little bit so we know where the shape files are. And up here, this is the file geodatabase. It is a single folder or directory, and within and it always has a GDB extension on the folder. And if we open it up, we see that we have a number of tables, and this is essentially what the geodatabase is. It's just a collection of tables, and some of those are your tables associated with your data, and others are system tables, and it manipulates and controls and keeps track of all the data sets within that single folder. So when you want to give somebody your data, you can give them the whole folder, tompkinscounty.gdb, and know that everything's contained inside of there. You don't have to worry about, like with a shapefile, did I give them all 3? Do I zip it? How do I do it? You can just grab this whole folder, zip it all down, and everything will be contained within that grouping.